Good day everyone! We are the 10th presenter and we will be discussing about mountain building. Mountains are magnificent and inspiring features. People love visiting them for hiking, skiing, and doing other fun outdoor activities. But have you ever wondered how these massive things were made? Have you ever thought how these features came to exist? Actually, not all mountains are created the same way. This discussion will help you understand how mountains are made, why they're different, and the cool stories hidden behind their features. So, let's explore together and find out how these incredible places came to be in our discussion about mountain building. But before we proceed, let us first identify our objective for this discussion. At the end of this lesson, you should be able to describe the formation of mountains that shapes the Earth's surface. What is mountain? Mountain, as we all know, is a large landform that rises prominently above its surroundings. It is typically characterized by having steep slopes, considerable elevation, and a peak or summit. Mountains are dynamic natural features sculpted over millions of years by the forces of Earth's geological processes. Now, how do mountains form? Mountains form in a process called mountain building. Mountain building refers to the geological processes responsible for the formation of mountain ranges on Earth's surface. It involves tectonic plate movements, collisions, and interactions that generate immense pressure, leading to the formation of elevated landforms with distinct geological features. Different mountains form differently based on its geological activity. To understand this further, let us proceed to the types of mountain building at convergent boundaries. But before that, let us first define what is orogeny. Orogeny, from the Greek word oros meaning mountain and genesis meaning origin, typically translate to origin of mountains. Orogeny is a process in mountain building or the geological forces and events that lead to the formation of mountain ranges on Earth's surface. It involves folding, faulting, and uplift caused by the collision, convergence, or interaction of tectonic plates, resulting in the formation of elevated landforms like mountains. Orogeny commonly or usually happens in convergent boundary. Now, as we all know, convergent boundaries are plate boundaries where two tectonic plates move towards each other. There are three main types of convergent boundaries. First is the oceanic-oceanic convergence. In the oceanic-oceanic convergence, island arcs are the type of mountain that can be formed. When we talk about oceanic-oceanic convergence, it is when two oceanic plates converge. One plate usually subducts beneath the other due to its density. The older one is subducted under the younger one because the older one is denser. Now, as the subducted plate sinks into the mantle, magma rises, leading to volcanic activity. This results in the formation of a curved chain of volcanic islands known as island arc. The Aleutian Islands off the coast of Alaska are an excellent example of oceanic-oceanic convergence. This chain of islands in the northern Pacific Ocean was formed due to the convergence of two oceanic plates, the Pacific Plate and the North American Plate. In this region, the Pacific Plate is moving northwestward and is being subducted beneath the North American Plate. As the denser oceanic Pacific Plate descends beneath the lighter North American Plate, it generates intense heat and pressure in the Earth's mantle. This leads to the melting of rock materials, forming magma. The magma produced in this subduction process rises through the Earth's crust and erupts at the surface, leading to volcanic activity. Over time, a series of volcanic eruptions created a chain of volcanic islands known as the Aleutian Islands. Next is the oceanic continental convergence. The type of mountain that can be formed in this convergence is the Andean-type mountains. When an oceanic plate collides with a continental plate, The denser oceanic plate usually subducts beneath the lighter continental plate. Subduction generates magma that rises to form volcanoes along the continental margin. These volcanic eruptions, coupled with crustal deformation and uplift, lead to the creation of long mountain ranges. Unlike convergence at oceanic-oceanic boundaries, convergence between oceanic and continental plates produces mountain belts that are much bigger and more complicated than island arc. In addition to uplift, compressive force can cause the continental crust to fold and thicken. As the crust thickens, higher mountains form. The Andes Mountain in South America is a prime example of this type of convergence. The Andes Mountains were formed by the collision and subduction of the oceanic Nazca Plate beneath the continental South American Plate, resulting in intense volcanic activity and uplift, creating one of the world's longest and highest mountain ranges. The third one is the continental-continental convergence. The type of mountain that can be formed in this convergence is the fold mountains. When two continental plates converge, neither is dense enough to be subducted. Instead, they collide and compress, causing the crust to buckle, fold, and uplift. These large-scale folding and faulting processes result in the formation of extensive mountain ranges with folded rock layers. The Himalayas in Asia are a prime example of mountain building resulting from continental-continental convergence. The Himalayas were formed by the collision between the Indian Plate and the Eurasian Plate. Around 50 million years ago, the Indian Plate carrying the Indian subcontinent started moving northwards towards the Eurasian Plate. As the two continental plates collided, neither could be subducted due to their density, leading to a colossal force of compression. The immense pressure and force exerted by the collision caused the Earth's crust to buckle, fold, and uplift, resulting in the formation of the Himalayan mountain range, one of the youngest and tallest mountain system on Earth.
After the discussion of the types of mountain building at convergent boundaries, let us move on to the types of mountain building at divergent boundaries. So a divergent boundary occurs when two tectonic plates move away from each other. This causes the new crust to be formed and can form underwater mountain ranges or rift valleys, such as Mid-Atlantic Ridge. As you can see here in the diagram, there's a mid-ocean ridge, so it occurs along divergent plate boundaries, where new ocean floor is created as the Earth's tectonic plates spread apart. Moving on, let us proceed to uplifted mountains. So what can be formed in uplifted mountains? So it formed the Adirondack Mountains in New York State. So uplifted mountains is when large regions of Earth have been slowly forced upward as a unit. Uplifted mountains also form when large sections of Earth's crust are forced upward without much structural deformation. When a whole region is uplifted, a relatively flat-topped area called a plateau can form. Given here in the diagram, there's uplifting force and there's a dome. So there's an increase in the vertical elevation of the Earth's surface in response to natural causes. Due to the plate tectonic movements, including mountain building or the gravitational adjustment of the Earth's crust after the material has been removed. So it results in uplift or added result in sinking, such as ice or sediment. Here's a beautiful example picture of the Adirondack Mountains in New York State. Last and finally, the Faultback Mountains. Faultback Mountains is formed between large faults when pieces of crust are tilted, uplifted, or dropped downward. So what type of mountain can be formed in Faultback Mountains? So we have here an example, which is the Basin and the Range Province. Basin and Range Province is a vast physiographic region covering much of the inland western United States and northwestern Mexico. It is defined by unique basin and range topography, characterized by abrupt changes in elevation, alternating between narrow faulted mountain chains and flat arid valleys or basins. Before we end our video, let's have a quick trivia. Did you know that mountains are the world's water towers, providing 60 to 80% of all freshwater resources for our planet? So, now you know how our mountains are formed. This is me, Jessie Estorque, together with my co-reporter, Shayne Petras. Thanks for watching!